Alright, so this video is about section 2.5, the chain rule. So, let's see, 2.5, the chain rule. Okay, that pen doesn't work very well, does it? That's brand new. The chain rule. The chain rule is a derivative formula applied to a composition. So by a composition, I'm talking about, we're trying to differentiate f, where we have g of x inside of f prime. Okay, so we have a composition where g of x is said to be our inside function and f of x is our outside function. We're going to talk about that more later, but just to give you the rule itself, the way the rule works is you take the derivative of the outside function, but you evaluate it at the inside function using your inside function, and then you multiply that times the derivative of the inside function. Okay, so just as a quick example, suppose I have h of x equals the sine of x squared. Okay, so the x squared here is our inside function, and so these instructions are telling us take the derivative of the outside function being sine. So I'm going to take the derivative of sine, which is cosine, but then leave some parentheses for your inside function because you want to evaluate your inside function. You want to evaluate your derivative at your inside function, so you're going to put the x squared there, and then you multiply the whole thing times the derivative of the inside. So the derivative of our inside is 2x. Good. So that's how the rule works. And so you'll notice that the key here is to figure out what is your inside function and what is your outside function. Okay, so just as another maybe quick example, I could have g of x. Maybe, I'm sorry about, maybe I shouldn't use g of x there. Let me use h of x again, just to be clear there. How about 2 to the x squared plus 2x plus 1. Okay, so the x squared plus 2x plus 1 is my inside function now. So h prime of x would be, I have my 2 to some power times the natural log of 2. That's the derivative of 2 to the x, right? Or 2 to some power. And now you put your inside function in there. I didn't leave enough room for my inside function. That's going to be a problem. So I'll use a little pen, x squared plus 2x plus 1. Sorry about that. And then we multiply the whole thing by the derivative of the inside function. So that would be times 2x plus 2, it looks like, huh? Good. All right. So so again, the key to the chain rule is to identify that you have a composition. So let's take a look at some more practice problems. This is activity 2.5.1. Okay, and so here we have the tangent of 2 to the x. And so this is a composition. 2 to the x is your inside function. So let's go ahead and just differentiate that. Okay, h prime of x then. Use my pen. The derivative of tangent again is, I guess we didn't use tangent before. The derivative of tangent is secant squared. So I'll have secant squared. And then I'm leaving room for my g of x. My g of x in this case is 2 to the x power. So I'll have a 2 to the x power. And then multiply everything by the derivative of 2 to the x, which is 2 to the x natural log of 2. Good. Now p of x is a product, right? So when you differentiate p of x, you're going to have to use the product rule. Good. And so when I take p prime of x, it's going to be the derivative of 2 to the x, so that's 2 to the x natural log of 2, times the second function, tangent of x, plus the first function, 2 to the x, times the derivative of tangent, which is secant squared. Good. So this was not the chain rule, right? This was the product rule. How about tangent squared x? Well, as a hint, remember that what that 2 represents right there. This is actually tangent quantity squared, right? And so this is easier to see. The tangent function is your inside function, and then the square function is the outside function. And so when we take r prime of x, right, the derivative of something squared is going to be 2 times that something to the 1 power, right? And then you put in your inside function, so that's going to be the tangent of x. And then we multiply by the derivative of tangent, which is our secant squared. Good. Next, we'll take a look at e to the tangent of x power. Do you see that that is another composition? Right, so tangent of x is our inside function this time again. E to some power is our outside function. So the derivative will be e to something, right? That's the derivative of the outside. And then put in your inside function, tangent of x, and then multiply by your the derivative of your inside function, which is secant squared. Good. The next one is what? Yeah, in the next one we would just use the sum rule, right? So I'm not going to do the derivative of that one. Okay, we'll just go to the next one. I don't know why they put that in there. Okay, z prime of x. So the inside function is tangent, outside function is square root. So I would rewrite this first. Remember how we rewrote the square root function? That's so I'm going to rewrite that as something to the 1/2 power, right? And the something here is the tangent of x. So the tangent of x is our inside function, and then the outside function is x to the 1/2 power. And so my derivative then is going to be, I take the derivative of the square root function first, right, just by using the power rule. And now I put my inside function in here, and then I multiply everything by the derivative of my inside function. Good. All right. So that is the chain rule. That's how the chain rule works. I think I'll probably have another video. Oops, excuse me. I'll have another video with a few more exercises. But I'll stop this one right here.